Hello, welcome to the video. In this lesson, we're going to be looking at section 7.4, where we're going to be adding and subtracting rational expressions. So adding and subtracting rational expressions we're going to follow the same rules as adding and subtracting fractions. We have to get um, we have to have uh, like like denominators, and once we have like denominators, we simply add the numerators together to get our result. Okay, so the first part that we're going to look at is adding and subtracting rational expressions that already have like denominators. So like we said before, when those denominators are the same, like we have here and here, the result is the same denominator. So since it was C in this example here, C is going to be the resulting denominator in our answer, and then you simply add or subtract the numerator as you seem fit. The only thing about this one is you can only combine like terms in the numerator. What I would advise you is to be really careful, especially when it comes to subtracting, is you got to make sure that when you're subtracting, especially that part B, if there's multiple terms, you remember that all of those values get subtracted, not just the first term. So for example, if I had something like, let's just say I put C minus C, and then on the top was 2x plus 3, and this was 5x plus 6, something like this, for instance, you're going to, the like terms, this is actually going to be 2x minus 5x, which is going to be negative 3x, and then 3 minus 6, which is also negative 3. Okay, now if for some reason this was, oops, if this was something like minus 6, then it's going to be like 3 minus a negative 6, which then is like a cross the line change of sign situation, and then you'll get a different result. Okay, so just be mindful of, especially when subtraction, when you're combining like terms, to keep in mind of those negative values. So all of these problems here have like denominators. So all we're doing is combining the numerator, all right? Combining like terms when necessary. So for number one, we know 12x is going to be in our denominator, and then it's just 8 minus 5, which is 3. And in this particular one, you can simplify this further because both 12 and 3 are divisible by 3, so this is going to be like 1 over 4x. Same thing with number 2. You're going to have 3x squared on the bottom. This is going to be 2 plus 1, which is 3, so this gets reduced to 1 over x squared. Number 3, 4x minus x, this will be 3x, and then it's going to be all divided by x minus 2. There's no canceling in this one because the x minus 2 is contained under subtraction, so this is my simplified solution. Um, Number 4, x squared plus 1 remains the same. And since 2x squared plus 2 can't be combined, we just write it as 2x squared plus 2. This one here is unique up on top, is you can factor this because you can factor out a 2. So this turns into 2 times by the quantity of x squared plus 1, all divided by x squared plus 1. These are the exact same, so those get crossed out to be 1. So my simplified expression here is just 2. So where it becomes just a little bit more challenging is when you have addition or subtraction with uncommon or unlike denominators. So what you need to do is you need to discover a way of making them like uh, like denominators, which means eventually you're going to have to find what is called the LCD, the least common denominator. So um, in order to do that for these types of expressions, especially with polynomials, what you're going to do is this. So this one here is there's not a fraction, but what they want us to do is they're asking us to find the least common multiple of these expressions. So I got 4x squared minus 16, and we got 6x squared minus 24x plus 24. So what you're going to do for these types of problems is you are going to try to factor each individual polynomial, and then what you're going to do is you're going to kind of take what's the same and then use that as your um, least common multiple, or LCD, once we get into um, adding and subtracting unlike denominators. So if I were to factor 4x squared minus 16, right off the bat I realize that I can take out a 4, so this is going to be 4 times by the quantity of x squared minus what, 4, and then this is a sum and difference pattern, so now I got 4 times by the quantity of x plus 2, x minus 2. Looking at the second value, 6, 24, and 24, those are all divisible by 4. So actually I'm going to write in 6 times by the quantity of x squared minus 4x plus 4. So now I go over here, and this is going to be 6 parentheses parentheses. It's a simple trinomial, so it's x and x. Same, second sign is plus, which means the signs are going to be the same, and minus here because they're both going to be minuses because of the first sign. Two values give me a product of 4. Sum is 4 is actually 2 and 2. So this one here is my factored out completely polynomial of 4x squared minus 16. This is my factored out completely polynomial of 6x squared minus 24x plus 24. So to find your uh, to find your least common multiple, what we're going to do first is I'm going to take a look at these numerical values in the front. I got 4 and I got 6. So between those two values, if I were to pick a common multiple with 4 and 6, the least common one would be 12. So what I'm going to do is I'm going to write 12 right here. Okay, because 12 goes into 4 3 times, 12 goes into 6 twice, it works out. But now what I'm going to do is I'm going to look at um, the variable terms here and here. So I notice that I have x plus 2, so I'm going to write that in, x plus 2. And then over here I have x minus 2. So if you look on the other side, I actually have a repeat of x minus 2. Now, since it's written twice, it only works for one set of terms. So since it was written already once, what I have to do is I just kind of have to write it again. So this is a unique situation where, yes, there's a repeat, but it only works for one of those values. I have to write them in for both. So my least common multiple for these two expressions would be uh, 12 times by the quantity of x plus 2 times by the quantity of x minus 2 times by the quantity of x minus 2. You can actually shorten this a little bit if you'd like and write it as 12 times by the quantity of x plus 2, and then since these are the same thing, I can write it as x minus 2 quantity squared. That's another way of writing it. Okay, so how is this useful when we are looking at adding and subtracting rational expressions? Well, So here's how we look at it in those types of problems. So if you look at this example, we have uncommon denominators. I have 9x squared and I have 3x squared plus 3x. They're not the same. So the only way that we can combine things is if they are the same. So we have to find that LCD. So what we're going to do is I'm going to look at each individual polynomial in each denominator. Can I factor anything? For 9x squared, I cannot, so I just leave it as 9x squared. Over here, I have 3x squared plus 3x. Actually, I can factor out a 3x here, and then in parentheses turns it into x plus 1. Okay, so now to help me out to find my LCD, what I'm going to do is I'm going to take a look at these two terms right here. I have 9x squared and I have 3x. All right, 3 goes into 9 3 times. So actually what I'm going to do is I'm going to write in 9. And they both have a variable x, so I'm going to write that in. And the largest exponent between the two terms is squared, so I'm going to write in 3x squared. What's left over is this x plus 1, so I'm going to fill it in with x plus 1. So my LCD in this scenario is 9x squared times by the quantity of x plus 1. So now what we're going to do is, now that I know what this is going to be my denominator, and how I like to write these things is I'll just, in order to avoid just keep writing, I'm gonna put like just like a smiley face to let you illustrate that, oh, I've already discovered the LCD and I'm not gonna write it in until the very end. So now I'm gonna look at the numerators 7 and x. So looking at 7, what you're going to do is you're going to get to multiply 7 by something. So looking at the denominator here, that originally it was just 9x squared. So what did I additionally multiply this denominator with is x plus 1. So since I multiplied x plus 1 um, to this part of the fraction, that means I'm going to multiply x plus 1 to the top here. Looking at x, what I additionally multiplied in this particular one is going to be 3x, because 3 times 3 is 9, and x times, so 3x times 3x is 9x squared. And it's already got the x plus 1, so that's what I additionally multiplied to that particular fraction. So now what I'm going to do is I'm going to multiply those terms there, which then gets us at 7x plus 7. So I distributed that, all divided by the LCD, plus 3x squared, all divided by the LCD. So now the last step here is to combine any like terms that we may have. So in this case there isn't. So I'm just going to write 3x squared plus 7x plus 7, and it's going to be all divided by the LCD, which is 9x squared times by the quantity of x plus 1. There's nothing else that I can cancel, so this is my simplified expression. All right, so now when it comes to subtracting, same rules apply. What we're going to do is, again, I need to factor out each individual denominator. So I look at 2x minus 2. I can factor out a 2 here, then it becomes, oh, sorry, I wrote it wrong. 2 times by the quantity of x minus 1. I look over here at this one. This one here's a trinomial, so I'm going to attempt to factor it out. Simple trinomial, x and x, same sign minus, two values that give me a product of 3, sum is 4, is 3 and 1. So looking here, my numerical value on the outside is 2. There is no numerical value on the outside of the second denominator. So my LCD in this situation is going to be 2 to start with, times it by the x minus 1 right here. And then I look at the second one, second denominator, I got x minus 3. That's not the same, so I'm going to write in x minus 3. But now I just have one x minus 1. So because of just the having just the one and not two of them, like I had the x minus 2 in the other uh, slide, I since it's a repeat of the x minus 1 from right here, I only have to write that once. If there was another one, then I'd have to write that one again. But because there's only one repeat, I don't have to write it again. So my LCD in this particular situation is 2 times by the quantity of x minus 1 times by the quantity of x minus 3. So looking at this fraction here, which is subtraction, it's going to be all divided by the LCD, which I put smiley faces, so I'm not rewriting that all the time. Looking at the top, I got x plus 2 in the first numerator. So now what I have to take a look at with this scenario is what did I additionally multiply to get there? So 2, I'm good. X minus 1, I'm good. So the x minus 3. So x minus 3 is what I have to multiply this top by to get to keep it consistent. So looking at the second one, I have negative 2x minus 1, and then it's going to be times it by what did I additionally multiply this by? So 2, yep, x minus 3, already good, x minus 1, I'm already good. So I just have to multiply that second one by 2. So from here, I have to FOIL out the first numerator, and I have to distribute the second numerator. So when I FOIL this out, it turns into x squared minus x minus 6, all divided by the LCD, subtracted by negative 4x minus 2, all divided by the LCD. So now from here, we get to combined like terms. So when we combined like terms in this particular scenario, there's no x squared on that, so I just leave it as x squared. Negative x minus a negative 4. So remember that's like a, so it's like writing it like this. So this is a cross sign. So now this turns into actually plus 3x. And then negative 6 minus negative 2, remember? So it's like negative 6 minus negative 2 plus, so that's minus 4. And this is going to be all divided by the LCD, which is 2 times it by x minus 1 times it by x minus 3. So what I want to take a look at here is, can I factor out this numerator even more, which means it may allow us to cancel some more out. So let's take a look. So this is going to be what? Parentheses, parentheses. I got x and x, different signs, large numbers attached to the minus. Are there two values? They give me a product of 4, but their difference is 3. It's 4 and 1. And then that's all divided by 2 times by the quantity of x minus 1 times by the quantity of x minus 3. In this particular scenario, x minus 1s do cancel. So what I'm left with in the numerator is x plus 4. And what I'm left with in the denominator is 2 times by the quantity of x minus 3. Here is an example. They're asking you to simplify. What these are called are complex fractions. All right, the reason why they're called complex fractions is they have, basically they have like a bunch of fractions But what you have to kind of do is kind of decode where's the big fraction. So like if you look, see, I got this big line right here. That's my big fraction in this particular scenario. So what I'm going to do is this, is how I'm going to rewrite this as, I'm going to rewrite this as 5 over x plus 4. And instead of writing it as a fraction, I'm going to write it as a division problem. So it's divided by 1 over x plus 4 plus 2 over x. Okay, the reason why I did it this way, and you can put parentheses around it if you'd like, is our goal in this particular instance is to get one fraction between that division symbol. So if you look here in in this first set of parentheses, I have one fraction, 5 over x plus 4. It's one fraction. I don't have to do anything with that one at the moment. But if you look at the second parenthesis, number 2 here, there's two fractions. There's the 1 over x plus 4, and there is the 2 over x. So our goal is I want that to be one fraction to get us going. So I'm going to go 5 over x plus 4. So this is just going to come down for the ride here. So looking at this second set of parentheses, what I only need to do is I need to have um, one fraction. So in order to do that, they have to be common denominators. So I need to find an LCD for this. And since I can't factor out x plus 4 and I can't factor out x, I'm just going to multiply them together. So it's going to be x times by the quantity of x plus 4. So I got LCD plus LCD in this case. So x plus 4, good. Multiplied it by x. Nope. So that means 1 gets multiplied by x, so it's just going to be x. Over here on the right, I got x. We're good. X plus 4, that's different. So I multiply 2 times by x plus 4, so that gives me 2x plus 8 when I distribute it. So now I just write in 5 over x plus 4, and it gets divided by, so now when I combine like terms in the numerator, I get 3x plus 8, and it's all divided by x times by the quantity of x plus 4. So I have one fraction on one set of the division. I got one fraction on the other set of the division. All right, so I've taken care of that first step. Once you've done that, now what you're going to do is you're going to switch it to a multiplication problem and then multiply it by the reciprocal. So 5 over x plus 4, turn that to multiplication, this gets flipped. X times by the quantity of x plus 4, all divided by 3x plus 8. So in this particular instance, it looks like x plus 4 and x plus 4 cancel. 5 times x is 5x, and all I have on the bottom is 3x plus 8, and I can't simplify anymore, so that is my simplified expression. Here are some other examples of complex fractions. What I'll do this first one here, number 10. If you have questions on 11 and 12, please leave me a comment. I'm more than happy to do them if you desire. So looking at number 10, like I said, let's break this up. So I got x over 6 minus x over 3 divided by x over 5 minus 7 over 10. So here I have two fractions in each set of parentheses. So now I have to kind of make each one fraction. So between 6 and 3, my least common denominator in this case is going to be 806. So 6 goes here, minus 6 goes here. I didn't change anything here, so this is just left as x. To get 3, I got to multiply that 2, so this is going to be 2x. And then this is going to turn into x minus 2x, so that's going to be negative x over 6 divided by, looking at the one on the parenthesis on the right, 5 and 10, so I can do 10 minus 10, multiply this one by 2, so this is 2x. I didn't do anything with this, so this is just 7. So now this is going to be 2x minus 7 all divided by 10. So now I have one fraction on the left, one fraction on the right. What I'm going to do is make it a multiplication. So it's going to be negative x times by 6 multiplied by 10 over 2x minus 7. Looking at the 10 and the 6, both of them are divisible by 2, so this turns to 3, this turns to 5. So now this becomes, what, negative 5x on the top, and on the bottom, this gets distributed as 6x minus 21. And yeah, and I can't simplify that any further, so that is my simplified expression for that example. And that is being able to add and subtract rational expressions. Hope this helps. Until next time.